Welcome to the tutorial on Bpsk, that is phase shift keying. Bpsk is a process by which the phase of the carrier is varied in accordance with the modulating wave. We will look into the modulation and demodulation of Bpsk, that is binary phase shift keying. In this particular circuit of modulation of Bpsk, we make use of an NPN transistor, a 741 op-amp, and input signal or the modulating signal m of t, which is a square waveform having a peak to peak voltage of 5 volt, and a carrier signal c of t having a peak to peak voltage of 6 volts. Similar to the concept explained in the ASK, the frequency of m of t is less than that of the carrier. Now let us analyze in detail as to how the modulation circuit works. Now let us analyze as to what happens when m of t is positive. When m of t is positive, the transistor, which is the NPN transistor, will have its junctions, base emitter and base collector junction, forward bias. Hence the transistor will act as a short as it is operating in the saturation region. The point B will be grounded and the equivalent circuit is an inverting amplifier circuit. The input to the inverting amplifier circuit is a carrier signal which is 6 volt peak to peak, or the equivalent is plus or minus 3 volt. For our consideration, we have considered plus 3 volt in this case, so that we can show that the output voltage is inverted with respect to the carrier. So coming to the equation for output voltage for an inverting amplifier, we have output voltage to be equal to minus R2 by R1 into Vin, which is equal to minus 15 kilo ohm by 30 kilo ohm multiplied with 3 volt, which will give you a value of minus 1.5 volt. If the input voltage is minus 3 volt, then the output voltage obtained in this case will be plus 1.5 volt. During the negative half cycle of m of t, the transistor, which is an NPN transistor, will operate as an open switch. Since it is in the cutoff region, the base emitter junction and the base collector junction are reverse biased. Since it is acting as an open circuit, the equivalent circuit will be a differential amplifier circuit. In this particular circuit, we have considered the two inputs Vin1 and Vin2 to be equal to minus 3 volt. The input voltages are actually the carrier voltages, which is equal to plus or minus 3 volt. But this is just for the analysis purpose. We have considered them to be equal to minus 3 volts. In order to analyze the differential amplifier circuit, we need to use the superposition theorem. The superposition theorem states that a circuit can be analyzed with only one source of power at a time. The corresponding component voltages and currents algebraically are added to find out what they will do with all the power sources in effect. So here, first we will apply the input voltage Vin1 and Vin2 will be grounded to obtain Vout1. The equivalent circuit is an inverting amplifier circuit, and we obtain the output voltage Vout1 to be equal to plus 1.5 volt. Again, note that the input voltage is a carrier voltage. It can be either positive or negative 3 volt. Just to show that the output voltage is inverted with respect to the carrier, we have made use of a negative carrier of minus 3 volt to obtain a positive output voltage of 1.5 volt. Coming to the second part of the superposition theorem. Here we have given input V in 2 and V1 is grounded to obtain Vout2. The circuit is equivalent to a non-inverting amplifier, and we obtain the output voltage Vout2 to be equal to minus 3 volts. So, the total output voltage will be the sum of the individual output voltages Vout1 and Vout2, which is equal to minus 1.5 volt. Now coming to the detection of Bpsk. In the detection of the Bpsk, the first part of the circuit is a difference amplifier, then you have an envelope detector and a comparator. We have already demonstrated the working of the comparator and the envelope detector in the video tutorial for ASK. Therefore, it won't be repeated in this tutorial. So, let us look into the circuit in detail. So, the first one is the difference amplifier, which is giving you an output at point A. Then you have point B, the output of the diode. The second part of the circuit is the envelope detector, and the third one is the comparator. Since the first circuit is a difference amplifier, we will be using a superposition theorem again in order to obtain the output at point A. So, input to the circuit, that is the difference amplifier circuit, is the binary phase shift keying signal, the modulated signal and the carrier signal. Modulated signal is represented by V in 1 and the carrier signal is represented by V in 2. Using the superposition theorem, Vout1 is obtained by applying the modulated signal, that is the Bpsk signal, and grounding the V in 2, which is C of t. In such a case, the circuit will then appear to be an inverting amplifier circuit, and the output voltage that we obtain, Vout1, will be equal to minus 30 kilo ohms divided by 15 kilo ohms multiplied with minus 1.5 volt, which is equal to 3 volts. Let us now analyze considering input V in 2 applied and Bpsk signal is grounded to obtain Vout2. In this case, the circuit will appear like a non-inverting amplifier with the resistances R3 and R1 appearing in the form of a potential divider network, and the resistance R5 and resistance R4 give the gain of the non-inverting amplifier. The input to the circuit is C of t, which is plus or minus 3 volt. So, we have Vout2 to be equal to plus or minus 6 volt, and the output voltage of the difference amplifier is Vout1 plus Vout2, which is equal to 3 plus or minus 6 volts. Next, we apply this voltage V out, which is nothing but the voltage obtained at point A, to the envelope detector in order to obtain the positive pulses as well as the waveform after the charging and the discharging of the capacitor, which will then be given as an input to the non-inverting comparator. The non-inverting comparator will give a saturated value. This saturated value, like the case of the ASK, will have a value of 28 volt peak to peak, given you use a MUA741 op-amp with a dual supply of plus or minus 15 volts. Here are the waveforms for Bpsk. M of t is a signal having an amplitude of plus or minus 2.5 volt, and C of t is a signal having an amplitude of plus or minus 3 volt. The collector output voltage is 0 when M of t is positive, and it is equal to C of t when M of t is negative. The Bpsk output voltage that we have obtained mathematically is minus 1.5 volt. This negative sign indicates that the output voltage is inverted with respect to the carrier C of t. Also, it is to be noted that whenever there is a transition from plus M of t to minus M of t, the phase of the carrier changes. Hence the name binary phase shift gain. Next is the waveform of the envelope detector. The envelope detector has the waveform which demonstrates the charging and the discharging of the capacitor. So this charging and the discharging of the capacitor is seen during the positive M of t, and it is equal to 0 during negative M of t. With the reference voltage designed appropriately, it is possible to demodulate the signal, and the demodulated waveform will be a saturated value which is equal to plus or minus Vsat equal to plus or minus 14 volt if we use a dual supply op-amp of 15 volts. Thank you.